Let's continue with the next presentation. We have now with us Luis Castillo, who's Sales and Solution Director of Sigenergy. And yeah, so we're moving now, as I already mentioned in the intro, from the module part to the BOS side of things. Sigenergy is having inverters, but is a solutions provider also with their own EMS. And so Luis will simply talk about truly smart solar prosumers, how you can managing on one hand the energy bills of the prosumer, and on the other hand, don't be too self-sufficient, but also support also support the grid. Luis, the floor is yours.
Thank you, Michael, and thank you everyone for joining. Let me upload my slides.
Just have to
Can you
move
see my
into presentation mode. We can see it, but just presentation
yeah?
mode.
Can you see it? Presentation mode.
Yep, good to go.
Perfect. Thank you. So, thank you everyone for joining. I'm Luis Castillo. I'm Sales and Solutions Director for Sigenergy in the UK and Ireland. And today I wanted to give you a very brief introduction to what we're doing as a company, our solution that we have there, but mainly how we are using AI and how we are increasing, the revenue of our clients, homeowners, and commercial clients through AI and optimization of the energy management. So the first thing I wanted to mention is about our Siren Store is the first product that we put in the market back in 2023. Sigenergy has the mission to basically to develop distribution energy technology in the market. That is our goal as a technology company. Everything you will see from Sigenergy is designed, manufactured, and developed by Sigenergy. I think this part is important because we, in the last 4 or 5 years, let's say before 2023, we saw how the industry, especially in inverters and battery, it was a little bit stagnated in terms of the main differentiation was becoming price. So innovation was a little bit lacking behind. So we saw a lot of gaps that needed to be filled, and this is how we came up with Sigen Store. More importantly, we saw that what used to be the requirement used to be a simple PV installation, a simple inverter installation, PV connected to an inverter, DC to AC conversion. Now the requirements are more significant. Storage is in the mix, energy management or smart solutions are in the mix. So we wanted to come up with a solution that involved all of that. So I won't go into full details given the time constraints, but I will explain you how it goes. So basically what we have is a 5-in-1 solution. The Sigen Store is an only one solution. It is a PV inverter, a battery inverter, a storage unit, an EV charger, and an energy management system. Everything designed by the same organization. At the top, you have the energy controller, which is going to be 3 things. It's going to be your PV inverter, it's going to be your battery inverter, and it's going to be your energy management system. You could have a single phase or a 3-phase version, and we have different ranges in terms of capacity. The second module is an EV charger. It is an EV DC fast charger, 12.5 or 25 kilowatts. This can be added at any point in time to the stack. And then what you have on the rest of the modules are battery packs that could go from 5 to 9 kilowatt hours, going through 8 and 6, and you can stack up to 6 battery packs under one energy controller. If you don't have an EV charger, if you have an EV charger, 5. So the idea with the Sigen Store is give you modularity and DC couple. In a DC couple solution, the system can be the size that you want. By just changing the energy controller from a single phase to a three-phase, basically you are changing your whole system from single phase to three-phase, which can basically you could change from a residential application to a commercial application with just changing one element. If you want to add more capacity, you can also parallel stacks. So you don't have to have one stack. Applications, we have a commercial solution which resembles what you are more used to in a residential scenario. It's a hybrid inverter connected to a battery stack, but we have made it a commercial version of it. Hybrid inverters, battery ready that go from 50 to 125 kilowatt hybrid, and battery packs that are 12 kilowatt hours modular. This is the first DC coupled modular solution in the market. So if you are more interested in this solution, please touch and we will discuss. But the point of today's conversation is to talk about energy optimization, which we have with the both solutions that I just presented. So your typical strategy when you have storage, it's either self-consumption mode, where your system prioritizes the use of PV and storage before importing to the grid. Basically, when there is PV, it goes to feed the load. If there is any excess after the load is satisfied, that will be stored. And if the only scenario where the system will import from the grid. And time-based control basically is when you tell the system when to charge and when to discharge. Okay? Energy can offer those charging and discharging strategies and more, but particularly it is the Sigen AI mode for what we are known. The system will take a combination of internal and external variables to make a decision automatically and decide when is the best time to charge and discharge. It will also take into consideration user preferences, for example, because not everyone is interested on trading electricity and profiting from electricity trading. Some homeowners are actually quite conservative and they just want to discharge their battery when the load is in need. So they gravitate more towards the self-consumption strategy. So we'll take that into consideration. Another set of variables will be internal parameters. The system will recognize how much storage, what's the capacity of the inverter, if it's single phase or three phase, and it will make decisions based on its capacities, obviously. And finally, the third set of parameters will be external. The system will take into consideration patterns of the house. It will take real-time and weather information, and it will take utility rate data connected, if possible, depending on the energy provider. We could connect directly to their API and read dynamic variables, dynamic prices if available. With the combination of all of these parameters, the system then will decide automatically when is the best time to charge and discharge the battery. As I mentioned before, having AI or a system that is charging and discharging your battery, storing electricity, doesn't limit your battery. This is one of the main parameters that the system will take into consideration. In our case, we have three. If you want to maximize profit, three scenarios. If you want to maximize profit, if you want to have a self-consumption approach, or if you want to balance approach those two. And this is the first information that is take into consideration based on the user preference, and it will impact the degradation of your battery based on the user preferences. Now we have we started with a in early 2024 or late 2023. We have seen since then significant results. We have got really good feedback. We have managed also, thanks to the feedback from the market, adapt and improve the algorithm. You can see some of the scenarios here. when we talk about self-consumption, remember we are discussing that self-consumption strategy, which is PV first or time of use. And then you can see the improvements that we have seen either by month and by country of those same systems using the AI. 15-20% increase, and the revenue is for this presentation, I wanted to address specifically a case in the UK and in Poland, which are representative of many cases that we have seen. As you can see here, this was a typical house with a 10 kilowatt system on the PV side and about 20 kilowatt hours of storage. So you can see the savings with AI and without AI. What's the differentiation? Sorry, I lost the view.
We can see it still.
Yeah, but I can't. Sorry.
Oh,
Sorry. Okay, apologies. So as you can see, the savings, we can show you the savings by month with and without AI. Values between 10, 20%, even 40% subject to the month can be seen, and even per quarter. So one more important that we take into consideration for this optimization, or the core of this optimization, is our algorithms that are also powered by AI. What you can see on screen now is the two main things that we need to predict. The blue line, the solid blue line, is the actual PV production on that day. This is a real case day. And the solid green line, it was our prediction for that day. We have access to the weather data and the forecast weather data, and with that, we are able to predict what is going to be the output of the PV. And then you have the solid orange line, which is the load scenario on that case, and the red line is our prediction for that load. And we are able to estimate the prediction by historical data that we have seen in the house, pattern behaviors. For example, a household wakes up early in the morning, there is a peak of electricity demand, everyone goes to school, they come back in the afternoon, there is another higher peak of demand. This kind of pattern is what we are able to identify. The more data we have, the more accurate the system will be. Can you see that these are 100% accurate? No, they are not, but they also don't need to be, because the most important thing is to identify the peaks. We were able to identify there was going to be a peak production around noon, and we were able to identify the peak loads of the peak points of the loads. Sorry. Like everything AI based, it will get better with time. So chances are that if we look at this graph a year from now on a similar day, those lines, our prediction and the real line, will be closer together. If you a scenario one of the system installed in the UK, the strategy here was, as you can see, the blue line represents the price for buying, and the red line, there was a dynamic price for buying, but there is a fixed price for selling. So the strategy was to charge the battery in early hours of the morning or late hours of the night. And then you can see when there is the peak of electricity starts, the family is waking up, the battery starts discharging. Now, it starts discharging at about up to 9 a.m. when the system starts charging again from the grid, importing electricity from the grid, even though there is PV and still storage available. Any other self-consumption strategy will continue discharging the battery until it's empty. For us, we start charging even though there was still some storage available, because we already know there is a bigger or a larger peak of electricity coming. So we start discharging when that larger peak of electricity starts again at around 3 p.m. and until the battery is depleted, because this is the most critical time for the energy consumption. It is also clearly identify, this is inside information also for the homeowner. You can see here that this homeowner could benefit themselves from accumulating more storage or increasing their storage size, which is something that ultimately, sorry, will increase. On another scenario, we have a price and a dynamic buying price. Basically, the starter was simpler here. The battery was operating on a charge and discharge cycling, basically trading electricity as much as possible because the electricity was cheap early hours of the morning and late hours of the night. And once the household start demanding for electricity, then you start a dynamic strategy of charging and mainly on buying electricity price. The idea is, again, normally is to reduce how much electricity the system is buying from the grid. In this case, you can see the improvement from a self-consumption or a typical self-consumption strategy to an AI strategy increased by 900% the savings. We have residential scenario where the system was operated in self-consumption. The idea was to use PV power when available and then use the storage battery if there was not enough PV or at late hours of the day. However, this strategy is highly dependent on the weather, especially, and it's going to create issues during autumn and winter seasons. An AI mode where again you have insight on the price and the weather, the system was able to trade electricity, basically behaving like the stock market, trying to buy electricity when it's low and selling it when it's high, because the patterns were repeated several. The battery represented essentially a 48% reduction on electricity bills, just the way you operate your system. There was no increase of hardware, there was no increase of an investment, it was just a change of strategy in the way the system is operated. Now, this technology is not just available for the homeowner, as I show you, it's also available for the commercial and it's also available for energy operators or VPP provider. This is not just technology that can be used for increasing revenue, electricity trading, but it's also technology that can be used to support the grid. Having hundreds of thousands of assets working in harmony at the same time will definitely have a response on the grid side. This is what we know as virtual power plants. So this is technology or energy providers or VPP providers are looking at, and then basically allowing them to participate in the flex market and also add more revenue streams for the homeowner or the commercial client. And that's all for today. There is a lot more to talk, obviously, but I wanted to keep it short for now. If you have any questions, and I'll answer them now. Thank you.
Thanks, Luis. Very interesting. I think there's one question in the chat. Maybe you can answer it there. We're a little bit delayed, so we continue with the last presentation. We will have you on the panel then also later on. Maybe you can answer it here in written form. Also to the guy, to Manas, who asked the question. Otherwise, we will also we can actually also refer to that during our panel.